first dressed in blue jeans, plaid shirts, and cowboy hat, which was the giveaway that it was a 3-circle. In total, 120 people showed up. Don't know why. Change the question. As party dress as follows. 59 people wore a cowboy hat, 45 wore both cowboy hat and blue jeans, 13 cowboy hat and plaid shirt, 8 plaid shirt blue jeans, 37 blue jeans didn't wear a cowboy hat or plaid shirt. So that's basically saying 37 people dressed up what? In blue jeans what? Only. So I can put that one in whenever the heck I want to, right? 2 people wore blue jeans, plaid shirt, and cowboy hat, some did not dress up in a costume. So we got a 3-circle. Make sure you have a box around your Venn diagram. Make sure it's all labeled. So we have blue jeans. I'm not going to use any short form. I'm not going to show any math on here. So you're not going to show how you get the math on these. They're just numbers, right? We've talked about that before. Where do I start? There's 3 options I can start with this one. Where can I start? In the middle. How many are in the middle? 3. Where else could I go? 7 is on the outside. And then I talked about that one that was an only. I can go in whenever I want. So 37 people dressed up in blue jeans, basically only. I know there should be 120 inside here, so I put this here to help myself out. All right. Now, 8 people wore a plaid shirt and blue jeans, so I put an 8 in there. What would I remember to do? Subtract, because and is what shape? The eyeball. So in the eyeball, I need to have 8. So how many is just here? 5. Cowboy hat and plaid shirt eyeball should have 13. So how many are here? 10. 45 on the cowboy hat and blue jeans. 45. So how many are in the blue jean cowboy hat only? 42. And then I gave you 59 wore a cowboy hat. So that's the cowboy hat circle. So how many are in here? Cowboy hats only. 4. How do I get the plaid shirt? Only. I don't know. I'll see what's left over. Up to how many? How many are total? 20. So how many are in plaid shirts only? All right. Well. Okay. How many party attendees dressed in a plaid shirt or blue jeans but not a cowboy hat? So or is what shape on a Venn diagram? A snowman. So I need plaid shirt or that's really loud. Plaid shirt or blue jeans, snowman. But then what do I kick out? The cowboy hat. So 37 plus 12 is 49 plus 5 is 50. How many? Numeric response. They filled in from left to right, correct? Is there a decimal on the first one? No. There's a decimal bubble and a decimal bubble there. Then 1, 1, 1, 1 here. The only place you can put decimals is in the second or third boxes. Okay? So if your answer is, for example, decimal 36, you have to go 0 decimal 36, right? Because there is no decimal bubble in the first one. Don't call someone over and be like, where's the bubble? There isn't one. You start with a 0, okay? If it's a decimal. High school running team consists of exactly 4 runners. Total 5 girls, 11 boys, or 6 boys. It's just how many people? 11. There were 11, and no one said it. Okay. Describe the team. If the team must have at least 2 girls, what unit are we in? Arms and palms. It has to have at least 2 girls. At least or at most. Is that standard of excellence? Or is that acceptable? I give you 2 standard of excellence questions. At least at most is standard of excellence question 2. Majority of them I made you guys do so many times that they don't seem like standard of excellence because you have to do them over and over and over. So at least 2 girls means 2 girls or what? More. I went to the So I need at least $2. I need $2 or more. So I need at least 2 girls or more. So where am I stopping at? 2 girls or 3 girls or 4 girls. Well, there's 5 of them, so I can keep going. Or 10. I have to stop because there's only 4 runners, even though there's 5 girls, right? Now, is this enough, or do I have to supplement it? Supplement. And the moment that this question is given as an numeric response reduces the chances of people getting it correct, right? There's no answers that you can kind of get. So we do 2 girls and what? 2 boys. 3 girls and 1 boy. 4 girls. Do I have to put the 0 boys? So really do boys and boys, girls for girls, teachers, golf clubs for golf clubs, hockey sticks for hockey sticks, parents for parents. What do we use in that happen? The comma, so we do 5C2 and means I what? Multiply boys 6C2 plus 5C3 times 6C1 plus 5C4. When you add them up, what do you get? How much do we get? 15. So to me, even though these are standard of excellence, when I see them on a diploma, I like them because I think you can do them. You practice them over and over and over. It's one that seems straightforward because you've seen it before, right? Okay, this from this unit. Odds in favor. Whatever comes after odds in favor comes where? First, right? So odds in favor of passing means passing comes first and its complement not passing. That's a nice way of saying failure. Not passing. You know, I just not pass it. Just not pass it. Yeah. Is it English? Okay, cool. Determine the probability that James will pass his math test. So they want the probability to pass. So how many passes? Remember, it's number of pass. I'm just writing this out in long form anyway. Number of pass over number total, correct? What do the odds do when you have the 2 numbers? What do you do to get the total? You add them together. So when I get odds, I'll always do this to help myself out. Total equals 5. So that I don't mess it up. Because some people will give me like, if it's 2 out of 3, it's not passing. Well, it's not 2 out of 3, it's 2 out of 5, right? Right, or total. So what would this one be, the probability of passing? Out of? This is getting an odds and having to produce probability, right? The next one says the probability will rain is 60%. Now I want odds from that. So I can go odds probability and probability to odds, right? So the probability of rain is 60%. Well, in order to have odds, I need the probability of not raining as well, right? What would it be? 40%, because they're opposites. It's either raining or it's not raining, correct? So determine the odds against. What comes after this comes what? Second. Odds against raining. So raining comes second. Its complement, not raining, is first. So raining is how many? 6. Yeah, 60. And then not raining is 40. Now I could take 20 out of each, right? But if you get stuck on that, did you not just go 40 divided by 60? I told you to do this. 40 divided by 60 in your calculator after enter and reduce it as a fraction, even though it's a side-by-side ratio. Or we can take 20 out of each and know that this reduces to 2, 2, 3. Wow, I wish the odds came to me in the water is 45. I'm not very often with it. I must have thought I was really funny when I made this question. Not gonna lie. I can envision myself laughing. Okay. The odds against Mrs. Lepp, this is where I Mrs. Lepp winning. So which one of these is winning? The 4 or the 5? Odds against Mrs. Lepp winning. The 5. See, look, I would have thought it was hilarious. It's even better than nothing. What do I do always? Underline it and say total equals 9. Now you determine the probability that Mrs. Lepp will not win. So probability of not winning. So then I put the total not winning, or the number of not winning over the number total, right? So how many are not winning? 4 or 5? 4 out of 9. The last one, the probability Scott will pass his driver's test. Oh, Scott's my husband. This is a really funny year. Oh, yeah. Maybe he's passing it. Maybe that's a good probability. Okay, a missed opportunity. So probability Scott will pass. So this is probability of passing, which is 5 out of 7. What does the 5 represent? What does the 7 represent? What does the 5 represent? Scott doing what? Scott passing. And what does the 7 represent? The total. Total number of times he's going, right? You got 7 times to pass 5. So it says odds in favor of Scott not passing. So it says odds in favor, whatever comes after that comes first, right? So odds in favor of Scott not passing would come first, and passing would come second. So how many times did he not pass? 2. And how many times did he pass? Because what should this add up to? 7. Right? So we can work our way backwards and forward between odds and probability, right? If you want to compare something though, if you want to compare which is better, like say they gave you the amount of the odds in favor of someone liking a restaurant, the odds in favor of someone not liking a different restaurant, and the probability of someone liking the other restaurant. And then you said, which one do I want to go to? So you'd want the one that they like the best, right? Would you compare them all, would you put them all into probabilities so you can compare them? Or would you put them all into odds? Probabilities is what you put them in, because odds, can you compare odds when they're out of different totals? Can you turn a probability into a decimal and say, oh, this one's 30%, this one's 35%, this one's 40, right? So if you're comparing something, you want to find out the least likely or the most likely or the least one that I want to pick or the most likely one I want to pick, I have to convert them all to probabilities. Okay? So we're going to open the notes from today. So we're here. So we've dealt with the lesson on odds. Today we're dealing with not exclusive, mutually exclusive and not mutually exclusive. Then what we have left is counting methods, which is basic probability, pros and cons. And independent and dependent. So after today, you have 2 lessons left in 30 days. Okay? You're going to have a closed book on this, and then you're going to have the unit test together on the 2 units, right? Your closed book on this is going to be on Monday, just so you know, because you're running out of time. Because guess what? Next week is our last full week. The week after that is social English diplomas already. You can't class, right? So the Monday and Tuesday were the social English diploma. It's mock is going to be. You choose to do it or not do it. You do a mock to replace or not. It's either do it in the morning on the social diploma or the morning on the English diploma. If you happen to have both, you're going to come talk to me. If you're a unique student, you can't write it on either. Okay? And that's okay. You can just talk to me about that. The mock is optional. So you can either do it or you don't have to, but it replaces your lowest mark if it's better. Okay. Thank you. Okay. So on Monday will be your closed book, and then on Monday will be your open book on probability. On Thursday will be your closed book on the 2 of them. So it's Monday and Thursday next week. Okay. If you're someone who hasn't written sign your story, you still need to. And if you're someone who hasn't written your cumulative, so we have a closed book and an open book left. But no more cumulatives. the mock is optional, right? The mock could replace the new. Some people choose not to do that. I have to have it done by the Monday or Tuesday of that week, if you guys only have the Wednesday, Thursday left with me, and I want you to be able to see your mom. So, people do not understand, it takes me lots of years to realize that people can't comprehend between mutually exclusive, not mutually exclusive, and independent and dependent. Now, mutually exclusive and not mutually exclusive events happens when you have one event happening, and it's either this or this. It's the word or that is key in mutually exclusive and not mutually exclusive. Independent events is when you have two events happening, and it's this and this. What's probability? It's this and then this, right? Two events happening. So, how I always narrow it down is I say, is it one event happening or two? So some people say, well, you rolled two dice, that's two events happening. Not if you just take two dice, roll them and drop them. That's one event, right? If I take the first dice, roll it, drop it, and then I take the next dice, roll it, and drop it, that's two events. If I take out a card from the deck, that's one event. If I take out a card and then I take out another card, two events. So between today's lesson and tomorrow's lesson, is it one event or two events? Okay? It is one after the other, so you can compare the two. Mutually exclusive or not mutually exclusive is the word or. I'm going to put that right beside your big bold print. Or. It's what's the probability of it being red or black. Well, that'd be zero on the card, right? What's the probability of it being a heart or a diamond, right? So it's word or. In mutually exclusive and not mutually exclusive, also permutations and not permutations, sorry, probability on Venn diagram questions are in this unit. Okay? And we've talked about mutually exclusive before in set theory. So here it says, consider the experiment of rolling a six-sided die and knowing the result. Let the event A be an even number is thrown, and the event B be an odd number. Mark the outcomes on the Venn diagram. So, what are the outcome options we have for in set theory? 1, 2, we're all talking 1, 3, painful, 4, that's it. 5, then 6, what about 7, 6, 7, 5. So A are the even, B are the odd. So in A I'm going to have 2, 4, 6. And B I'm going to have 1, 3, 5. What can we say about A and B set theory? A and B are what of each other? They're disjointed. There's nothing in common, right? One circle, other circle, completely nothing in common. So they're disjoint sets. No overlap. Remember that's what disjoint sets stands for? For example, A and B would result in the empty set. Remember that 0 with the slash? That's how you know the mutually exclusive as well. Mutually exclusive is disjoint kind of. Okay, what's an A or B? What shape is or? Starts with S. Snowman. Doesn't matter that the two circles of the snowman aren't touching, it's really a weird deformed snowman with sign that you shove them together with the snowman. What we're going to have for options? 1, 2, 3, 4, 5, 6. A has 2, 4, 6. B has 1, 3, 5. So that is set theory. What we just did now, that was set theory. That's the unit on set theory. It's when I ask you for probabilities about that Venn diagram that turns into this unit. Okay? So of the 4 lessons in probability, 2 are from separate units, from 2 previous units. One is terms and columns probability, take terms and columns, make probability of it now. And the other one is set theory, now takes probability. Okay? So we want the probability of A. So probability of A just means the number of A over number total, correct? How many are in A? How many are in total? Do I get? Probability of B. 3 out of 6, which gives me a half. A or B. 6 out of 6. What happens when I have a probability of 1? 100%. It's happening. Makes sense, because if it's an A or a B, it's all of the numbers, right? So the probability of A or B, 100% is going to happen. And then A and B, 0 out of 6, which is 0. There's no chance that I'm going to pick a number that's in A and B, because there are no numbers in A and B. No overlap. They're mutually exclusive. So here it says, notice that in the Venn diagram, the circle A and circle B have no area of overlap. The sets A and B are disjoint. And the sets A and B have no common outcomes. They are mutually exclusive events, which we talked about. Right? Okay, flip it over. Examples of mutually exclusive events. Choosing one card. You see how I'm doing one event? I'm choosing a card. Probability of red or black. Why are those mutually exclusive? Are there any red black cards? No. Keep flipping a coin. I'm flipping one coin, one event. Probability of heads or tails. Are there any heads tails coins? No. On one side. Rolling 2 dice at once. I take 2 dice, I roll them. The probability of the sum of 7 or an even sum. Those are completely mutually exclusive because there are no even sums of 7. Right? 7 is an odd. So mutually exclusive events always have one thing happening. For example, spinning a spinner, tossing a coin, rolling a dice, if they die, choosing a card, and determining the probability of blank or blank happening. The key word you're looking for here is or, and the outcomes have no overlap. So the word or and no overlap is mutually exclusive. The word or and overlap is not mutually exclusive. So this is the thing. When P of A and when P of A and B result in 0, that means there's no overlap, right? P of A and B, there's no eyeball. The eyeball is empty, there is nothing. Then they're mutually exclusive. So, investigating non-mutually exclusive events. Consider the experiment of rolling a dice and knowing the results. Let A be even numbers, an even number is thrown, and B be multiples of 3. Multiples of 3 start at what? 3 and go up by 3. So only 3 and 6, correct? You try this one out, there will be overlap. I didn't make a Venn diagram of that. You try this one out, fill in all the answers. We still have 1, 2, 3, 4, 5, 6. A has even, so it's still 2, 4, 6. B has what numbers? 3 and 6. So what's my overlap? 6. And then this one has 2 and 4. This one has 3 and I'm done. What am I missing? 1 and 5. They go outside, right? So what are the answers in A or B? And we know this is an or because if I write it out as the word and, it looks stupid. So therefore, it's or. That's how we read it. Which is also stupid for that. So, or. What shape is or? Snowman. So what's in the snowman? 2, 3, 4, 6. This is and because if I write it, it works to make the word and. What's an and? Just 6. So what's the probability of A? 3 out of 6 didn't change because A didn't change, right? So B completely changes. So it's going to be 2 out of 6, which reduces to a third. Or is 4 out of 6, which reduces to 2/3. And A and B would be 1 out of 36. What if I gave you this? What did I do when I had 2 knots? What did I tell you to do, remember? You can put the knot in. Yeah. You put the knot outside the bracket. And you switch the end for or. So if I want the probability of not A or B, I'm asking you for what's not in the snowman, which is a lot easier to digest than not A and not B. Right? So this would be 2 out of 6. notice that in this diagram, put together, that's what it is. In this Venn diagram, the circles A and B have an area of overlap. As a result, the A and B are not mutually exclusive. Notice that the probability of A union B does not equal P of A plus P of P. So if I actually take the probability of A or B is 2/3, and I add 1/2 and 1/3, I don't get 2/3. This does not happen. Now, if you look at your formula sheet for a second here, the top two formulas are mutually exclusive or not mutually exclusive, right? And they're alphabetical. So this one here is mutually exclusive because there's no overlap. I don't have to take off the overlap. But this one is not mutually exclusive. And why do I take the overlap off? Because I counted, let's say, the 6. If I add these up, I counted the 6 in the probability of A. I counted the 6 again in the probability of B. So I have to take one of them off. Because you counted 6 twice, and you can't count it twice. So I'll show you what I mean. So if I do probability of A or B in this case, it was 2/3. And if I take probability of A, that's 3 out of 6. I'm going to leave it as a 6. 3 out of 6. And then probability of B is 2 out of 6. And I'm going to put this back to out of 6. Why is it recording? I'm going to put this back to being out of 6. So this one would have been 4 out of 6. If I put these together, that's 5 out of 6. Why is this right-hand side 5 out of 6? Because, yeah. Because I counted the 6 in the A and I counted the 6 in the B. So I have to take off the overlap. And what's the overlap? One of them. 1 out of 6. So this will get me 4 out of 6. And this will equal 4 out of 6. So you can't double count something. You know what I mean? So there's no overlap. You can count the two probabilities. Proof you have 4. Right? I counted this circle that was by itself. I counted this circle that was by itself. I had the probability of both. Remember, there's no having overlap. If you have overlap, you have to subtract the overlap off. So these are your formulas, and on the formula sheet, they're in alphabetical order. Mutually exclusive, no overlap, so I don't have to subtract it. Not mutually exclusive overlap, so I have to subtract it out. Fun fact: the formulas are in alphabetical order. Independent, dependent, or not. Mutually exclusive and not are. So the M comes before the N. Experiment 1. In each case, state whether the events A, B are mutually exclusive or not. In order for events to be mutually exclusive or not, only one experiment can be done. So, for example, a die is rolled. There's another experiment. Yep. So, a die is rolled. Even number occurs or an odd number. Is there overlap between even and odd? Are there any even odd numbers? No. So this would be mutually exclusive. Next experiment, a card is drawn from standard deck. Is that one thing happening? Picking out a card. There's no one of that. Now, what's the chance that it's a face card or a club? Are there any club face cards? Yeah, Jack, Queen, and King. So this would be not mutually exclusive because they're overlapping the events. The next one, experiment. Two dice are rolled at the same time. So I take the 2 dice and I roll them. Is that one event? I start like this and out like this. That's one event, right? Both seem to show the same value. So that's like 2, 2, 3, 3, 4, 4. Why 6, 1, 1? I'm not sure. 5, 5, 6, 6. Event B, the total score is 11. Do any of those total means add to 11? No. So what are these 2 events? Complementary events will always be mutually exclusive if they have nothing in common, like rain and not rain. Odds and not odds is the same as odds and evens, right? They're all complementary. So here we have, consider the experiment of drawing a face card from a standard deck. Or drawing a face card, try again. Drawing a card. One event or two? Is that one experiment or two experiments? I'm drawing a card. One. So it's mutually exclusive or not. Two, independent or dependent. So if I drew a card and then another card, I can say, is it independent or dependent? Draw one card, mutually exclusive or not. Okay? The following events are defined as event A is a face card, event B is a red card, event C is a club, event D is an ace, event E is a black card. Which pairs of events are mutually exclusive? Of these pairs which are complementary. Try this up. Which of these are mutually exclusive? B and what, sorry? And E. Those are also what? Complementary. Any other ones have nothing in common? A and B and face card and an ace. Are they complementary? It's half the deck one or it's part of the deck one and then the other part would add 52? No. There are 12 face cards and there are 4 aces, which is 16. Complementary would mean if you added both of them up, you get 52. You get all the cards. Okay? Anything else? There are C and which one? Yeah. B and C, red clubs don't exist. Are they complementary? If I add all the red cards and the clubs, so they're 52? Right, it's 39. They're not complementary. Okay, events have been represented in a Venn without an extra N. Venn diagram. State all the pairs of events that are mutually exclusive. So which of these are mutually exclusive? Which of these have nothing in common? You tell me. A and B. What else? A and C. A and D. And there's one more that people miss. B and D. They overlap with C, but not each other, right? Okay, now we're flipping over. So it says, use the given information as the probability formula to determine whether the events A and B are mutually exclusive. So if they're mutually exclusive, then they use the first formula, right, on your formula sheet, which is P of A and B. Try again. That's an or. P of A or B equals P of A plus P of B, because it's an or, you add them, right? If they're mutually exclusive, do I have to subtract off overlap? Good question. If they're mutually exclusive, do I have to subtract off overlap? No, mutually exclusive doesn't have overlap, right? They should be mutually exclusive. So if I fill it into this formula and left side equals right side, it's mutually exclusive. If I fill it in and left side doesn't equal right side, then there's overlap that I just didn't take into account, but it's not, right? So we have 7 over 12 equals a quarter plus a third. You could type these into your calculator. I'm going to do it mathematically. And I'm multiply them by 3 to get a common denominator. Multiply them by 4. And I get 7 over 12 equals 3 over 12 plus 4 over 12, which is 7 over 12. I filled it into a mutually exclusive formula and it works. So what is this? So with these ones, I am drawing 8 cards, one experiment. Cool. Do this or this, right? From a standard 52, use the formula to determine the probability. So I want the probability of a 9 of diamonds or a heart. So probability of 9 of diamonds or a heart. I have 2 formulas to use when I have or. I have mutually exclusive, which is the top one, or not mutually exclusive. So I have to decide, is there overlap or not? So, in this case, are there any 9 of diamonds that are hearts? That's okay? No. I have to add 2 of them, and I don't have to subtract. Because there isn't. It's mutually exclusive. So I'm going to put an ME here for myself. It's not me, it's mutually exclusive. So all I do is I add the two, so I do probability of 9 of diamonds plus the probability of a heart. How many 9 of diamonds are there? There's 1 9 of diamonds. Out of how many? 52. How many hearts are there? Quarter of the deck. It's an unlucky number in multiple flow. 13. So there's 14 out of 52. Which reduces to 7 out of 26. You try the 9 or a heart. See if there's any that overlap. So y'all pick them off if there is. So this one we want the probability of a 9 plus the probability of a heart. Are there any 9s and hearts? Yeah, what is it called? The 9 of hearts. So we're counting the 9 of hearts in this one, which is 4 out of 52, correct? Plus we're counting the 9 of hearts in the hearts, 13 out of 52. So we've counted the 9 of hearts twice, essentially, right? So we have to take off the 1 9 of hearts. And so we get 16 out of 52, which reduces to 4 of 13. Remember, or always means plus sign. That hasn't changed the whole time, right? So here we have lots of different shapes and colors of placed into a bag. There are 3 cubes, 1 blue, 1 red, 1 green. There are 2 pyramids, 1 red, 1 yellow. There are 5 cylinders, 1 blue, 1 yellow, and 3 red. Now determine the probability that a block, one experiment subject random, will be a pyramid or a cube. Are there any pyramid cubes? Nope, that's no overlap having subtracted. Red or a cylinder. Are there any red cylinders? Yes, so we're going to have to subtract. So I'm going to get you to do example 6. Example 7, you're going to have to do a Venn diagram. Flip over. Example 8, you have to do a Venn diagram for. Example 9. Example 10. 11 we'll do together. So you try this out 8. We're going to start at 6. 6 to 10, inclusive. Okay, work on those.